Hello there, and welcome back to physics. Today we'll be talking about forces, relative motion, and the circular motion of objects.
First, we'll be talking about forces. A force is a push or a pull or an object that can cause a change in acceleration based on the object's mass. If the object has a large mass, it takes a larger force to produce the same acceleration on as it would on a smaller object.
Next is friction. Friction is what keeps objects from continuously moving in a direction after they have experienced an acceleration. The force of friction can be determined by multiplying the coefficient of friction, which depends on the material the object is moving across, and the normal force of the object. The normal force of the object is the force that the ground pushes back up against an object which is being acted on by gravity.
Relative motion is what occurs when two objects are moving or not moving in relation to each other. For instance, if two people are both moving 5 meters per second to the west, in relation to each other, they're not moving at all. If one of them were to stop moving, and from the point of view of the other person, they would appear to be moving 5 meters per second to the east. This concept also applies with boats and aircrafts with wind speed and the speeds of currents. If the current is flowing with the craft, then the velocities are added. If the current is flowing against it, they're subtracted.
Circular motion has to deal with the movement of objects in the shape of a circle. When objects move in a circle, they always experience an acceleration towards the center of the circle. To find the acceleration, we just need to know the velocity of the object and the radius of the circle. Once we have the centripetal acceleration, we can multiply it by the mass of the object to find the centripetal force.
If you're traveling in a vertical loop, there are some special cases at the top and at the bottom. At the top of the loop, if you're traveling at the slowest possible speed required to keep you going around in a loop, there will be no tension in the string if you're swinging something on a string, or normal force with the track if you're on, say, a roller coaster. The only force you will experience is gravity, straight down. Meanwhile, at the bottom of the loop, you experience both gravity and tension in the string, which is now pulling in the other direction towards the center of the circle. That's all for today. Whee!